Wow, nice crowd. I don't know about you guys, this is going to be a hell of an ayahuasca circle to be in. No, Aaron Rodgers is in the next room over, actually, so no, totally kidding. If you are here for to trip or not to trip, you are in the right room. And I'm really looking forward to today's discussion. So we're going to discuss what has been a long-running debate in psychedelia, and that is whether patients need the trip to get better, or whether a new generation of psychedelic molecules can be engineered to mitigate hallucinations while preserving at least some form of efficacy for patients. There's no doubt that having the trip is an incredibly enlightening experience, and I think many of us, including myself, would attest that it has offered profound insights, not to mention it is pretty freaking fun as well. But sadly, for a large swath of patients, a multi-hour session with multiple hours of post integration and all the cost involved in that just isn't affordable, and we're unsure whether health insurers are going to be willing to reimburse these first-in-class therapies. So while we won't directly speak to this today, I do think a corollary to this discussion is one of patient access, affordability, and health equity. Now, one thing I want to make clear is I don't think anyone's arguing that patients who can afford and wish to have a hallucinogenic experience should be deprived of that option. Rather, I think the debate is over patients will be limited to a one-size-fits-all strategy where they're funneled towards a small set of hallucinogenic compounds, which will be expensive therapies, or whether the future psychedelic drug discovery will be a prolific one with a vast pharmacopeia spanning from long-duration trips to short-duration ones, and even potentially non-psychedelic psychedelics, for lack of a better word. This panel is here to discuss whether that future is a possibility. So now to a quick round of self-introductions. I'll start with myself, and then we can go down the line. I will be moderating this panel, so hopefully this is the most you will hear from me. And I do want to start by just apologizing to everyone. I'm sure many of you glossed the description and just saw Tim, Austin, psychedelics, and thought this might be Tim Ferriss on stage. So I want to apologize. Sadly, Tim Schlidt here instead. But co-founder, partner at Palo Santo, alongside my business partner, Daniel Goldberg. We're a $50 million psychedelic-focused venture capital fund that launched in 2020 with a focus of backing transformative companies in the space, even before it was cool to invest in psychedelics. So with that said, I'll pass it over to you, Dave, and we can go down the line for a round of self-introductions.
So my name is David Nichols. I started doing research on psychedelics, not hallucinogens, psychedelics back when they were still called psychotomimetics as a graduate student in 1969. I published hundreds of papers in this field. Started the Heffter Institute in 1993 because there was no government funding. We funded the seminal studies at Johns Hopkins and New York University. I made the MDMA for MAPS phase 1 and phase 2 studies. Made the DMT for Rick Strassman's studies, made the psilocybin for all the Johns Hopkins studies, and have been a promoter and educator and tried to get these drugs brought into modern medicine for most of my life. I retired from Purdue University in 2012, and I've continued to work in the field as much as I can since then. So that's me.
Hi, everyone. My name is Rachel Yehuda, and I'm a professor at the Mount Sinai School of Medicine, the ICANN School of Medicine at Mount Sinai, where I also direct the Center for Psychedelics, Psychotherapy, and Trauma Research. I'm also director of mental health at the Bronx VA. I'm relatively new to the field of psychedelics, but the reason that we started a center is because there are not a lot of good treatment solutions in mental health right now. And after working in the field of really trauma and PTSD for more than 3 decades, I became very interested in the possibility that there might be a new way to approach it with psychedelics.
Thank you.
So I'm Charles Nichols. I am a professor of pharmacology at LSU Health Sciences Center in New Orleans. And I have been around psychedelics my entire life. I remember going into the lab as a little wee lad, and my father showing me some chemistry tricks around the lab. Didn't quite know what he did till I was a little bit older. Actually went to graduate school, got a degree in fruit fly eye genetics, didn't want nothing to do with psychedelics and pharmacology professionally. But I found my way back into the fold, been working on psychedelics now for 25 years. And I remember when I was going on the faculty trail trying to find a position 20 some years ago, my father was like, "What are you doing? This is going to be the kiss of death. Nobody cares about psychedelics." So fortunately, I didn't listen to him. And we've had a good productive collaboration over the last several years.
Hey, I'm Hamilton Morris. I have spent over a decade making a documentary series called Hamilton's Pharmacopeia that was dedicated to various aspects of psychoactive drugs with a focus on psychedelics, and it was dedicated to the anthropological dimensions of the way psychedelics are used in different cultures, as well as the chemistry and the pharmacology and the various legends in that space, including Dr. Dave, who is profiled in one of the episodes. And during that period, I was also working with a chemist named Jason Wallach at a small pharmacy school in Philadelphia. I've been doing that for 13 years, but in the last 2 years, I've shifted entirely to chemistry work and now full-time make psychedelics at St. Joseph's University because there is a new opportunity to do this that certainly did not exist when I first became interested in it.
All right, so now to our discussion. So I want to first just kind of caveat that we're going to break this into 2 sections. So the first section, we're going to dive a bit more into what we call mechanism of action. And that just means, what psychedelics do once they're consumed, once they enter the body. And I just want to lay the groundwork that there is a biological layer going on here. I think in the media coverage of psychedelics, these are kind of shrouded in mystery. It's like you take a magical potion and poof, you're off to the land of the machine elves. But I do want to establish that there is something going on. So that'll kind of be the foundational layer we establish. And then I think that'll be a nice, that'll kind of be a nice substrate for the next part of this debate, which will be, do you need the trip or do you not? So, which I think that'll be a lively discussion. So I guess, Dave, would you mind just kind of filling the audience in on how psychedelics work, from the receptor level, to kind of the neural cascade involved, the neural circuitry.
How much time we have?
We can take them and see.
So there is such a thing in the body called receptors. They're called G protein coupled receptors. About 40% of all the prescription drugs are targeted to those various G protein coupled receptors. And there's one in the brain that's particularly relevant to psychedelics. It's called the serotonin 5-HT2A receptor. Evolutionarily, it's a very old receptor. You go back and you find it in single-celled organisms way back in evolutionary history. So nature has evidently thought it was a very important receptor, and it's been retained up into us as primates and humans. And that receptor is located in a very interesting place. We know that in humans, what makes us different is our cortical function, our higher functions. So in the outer layer of the cortex are these cells, processing cells, called pyramidal cells. And they actually shape like little triangles or pyramids. And they traverse the cortex from the exterior dura area in toward the center. And they're I envision them as being like central processing units, like in a computer. They receive input from lower cortical centers, from emotional centers, movement centers, etc. They receive both inhibitory and excitatory signals, which impinge on these cells, and they sort of integrate it together and decide what all these signals mean. And they're packed in the cortex, they're stacked together, and so those of you that understand computers, I would say the cortex is very much like a parallel processing computer, where you have all this processing power. Imagine all the information that comes in. It's being processed, put into these cortical pyramidal cells, and they sort of create our reality for us. And that's sort of a missing link in terms of how that happens, but they're the functional part of the brain. Now, on one part of these pyramidal cells, the part that leads down into the cell body itself, the serotonin 2A receptors are expressed on the surface of the neuronal membrane. And when you activate a serotonin 2A receptor, what it does is it changes the membrane potential, the electrical properties of the pyramidal cell. It makes them more excitable, they fire more easily, and you could say in electrical terms, it increases the gain of those cells. So that things that normally are not processed, say unconscious material, etc., those are normally below our level of conscious awareness, but those can be accessed by these neuronal cells when they're more excitable. So the serotonin 2A receptor increases the excitability of those pyramidal cells. And you can imagine, those of you that know anything about a computer, if you went into the central processing unit in a computer or any part of the electrical connections, and you changed the properties of that, you made the CPU more sensitive or overclocked it and processed fast or whatever, you're going to change the property of the computer. The same thing happens in your brain. When you make those cortical cells more sensitive, increase their gain, you change their properties as processing units, and they can include more information that's coming in. So you have unconscious material, emotional material is now below the level of ordinary consciousness, but when those cells are activated, the 2A receptor is activated, those cells are able to process lots more information. So we have a whole lot of stuff that normally is below our level of conscious awareness being accessible to our conscious awareness, and psychedelics do that. Stan Grof, who was one of the most prolific researchers, early researchers of psychedelics, said that psychedelics are non-specific amplifiers of unconscious processes. And that's exactly what happens. It amplifies things that are normally below our level of awareness. So that would be one way to think of these. So it's like a massive parallel processing computer, and we've changed its electrical properties, so now it's processing faster and processing more information.
Yeah, thank you for that. That's really helpful. And Rachel, I'd like to turn to you of kind of building up from the pharmacology, the neurobiology, now to the human layer. As a clinician, would love for you to kind of highlight what we observe in patients both during the experience and then after the experience. I mean, there's pretty remarkable remission statistics around mental health disorders. Would love for your take.
Sure. When a patient takes a psychedelic, before they take it, they have to be prepared for it. So a very important thing to understand when using psychedelic-assisted therapy in a clinical context is that one of the things that's going to very much determine what people are thinking about and processing during their psychedelic journey is what their intention is for taking the psychedelic to begin with. So patients really come in and they have a list of things that they want to look at. We work with patients that have post-traumatic stress disorder, and a lot of them want to no longer have PTSD, and they know that that involves some engagement with what happened to them that they really have been too afraid to do or not thinking that they want to do because the material is too hot. So every time that they've tried to kind of think about what has happened to them before or try to do cognitive behavioral therapy that encourages you to talk about the trauma, they get waves of distress, the self-judgment, the shame, the humiliation, a lot of fear of being in that same kind of biologic state that they were at the time of the memory. When they take the psychedelic, the mindset changes around that all of a sudden the fear of distress becomes more like a curiosity. And although there can still be fear there, the curiosity overpowers. The idea is that the drug puts you in a state of introspection. And the introspection also is accompanied by a lot of self-compassion and lack of negative judgment and interpersonal trust for the therapists who are there, so that this material that seemed very difficult to access before is now right there and available. And because of the introspective process under these conditions, and often they feel kind of good too in their body, at least for waves of the journey, which really helps when people do not normally have that, they're able to have an insight. They're able to think about the trauma in a different way, or think about what purpose the symptoms are serving, or how they can approach their lives in a different way. And that insight will galvanize change, because if you really work with what you've seen, you can come out to a set of behaviors or a set of ways that you can now organize your life that is different. So one very powerful example is you can let down your body armor of anger, because you realize the anger is protecting something very vulnerable, but maybe you don't need to do something like that. So you can approach your family differently. That's one example. So what happens is certainly facilitated by receptors and all of that, but there's also an incredible psychological process that is also going on that has biologic counterparts that are not only expressed acutely, but months later, you can even see changes, perhaps even in epigenetic, in epigenetic marks and brain imaging markers to show the enduring effects of it.
Do you mind just hitting on that too, epigenetics, what that is, the role that may play in mental health disorders? And I don't know if psychedelics, if the suggestion is they play some role in modulating that.
Yeah, so epigenetics simply refers to the way to the mechanisms that regulate gene expression, the things that turn our genes on and off. And about, I don't know, maybe 10 or 15 years ago, epigenetics really became something that neuroscientists started to look at in the context of mental health as it became, as we started to learn how to measure epigenetic marks. And so it turns out that when you have profound environmental experiences, this can alter the way that some of your genes function and cause rather enduring changes in the way genes are regulated, and particularly stress-related genes. And epigenetic changes have been found in the context of trauma and PTSD. So we began a research program many years ago to try to see whether various treatments for PTSD affect epigenetic changes of the stress-related genes that are presumably brought about by trauma. And we found that even cognitive behavioral therapy can result in some changes in stress-related epigenetics. We were very excited about that, particularly in responders, and that furthermore, you can actually predict whether somebody will respond to therapy, perhaps in part by looking at some of these epigenetic markers. So recently, we were able to do a study with the participants from the MAPS phase 3 trial of MDMA-assisted psychotherapy in PTSD, and look at some epigenetic marks on that stress-related gene, the glucocorticoid receptor gene, before and after the MDMA therapy compared to placebo. And we found changes in the same gene as predictors of response, but that the response after treatment was greater in the MDMA group. Now, these are not the acute effects of the drug talking. These are kind of the enduring effects of having done the processing and kind of coming out to a different place of symptom reduction. So there are two things that happen. There are the things that are happening immediately, and then the enduring effects based on the cascade that is initiated by those acute effects.
That's really helpful, and I like this kind of connection between the biological layer and then kind of clinical observations and what the subjective experience tends to look like. And Chuck, I'd love to turn to you just as we're kind of on this topic of mechanism of action. You've done some really pioneering research around anti-inflammation and the quality psychedelics have in kind of mediating inflammatory pathways and tempering that. We know that neuroinflammation is correlated with many mental health disorders. Now, whether it's causative is a different question. But would love for you to just kind of highlight some of the research you've done, because I think that is pretty mind-blowing that not only do we get a lot of relief from mental health disorders, but there could be anti-inflammatory qualities. And could that have some bearing? Could there be kind of a tempering of neuroinflammation? Could that be part of sort of the biological effect at play here?
Yeah, and we discovered that psychedelics were really potent anti-inflammatories several years ago, and it was a surprise. We serendipitously found this in the course of doing some assays and followed up on it, and the anti-inflammatory effects of some psychedelics are just super potent, 30 to 50 times less than the behavioral levels to have full therapeutic efficacy in several different models that we've looked at. And one of the reasons it was surprising, as my father has alluded to, he's talking about psychedelics and the serotonin 5-HT2A receptors in the brain. Well, it turns out that the 5-HT2A receptor is the most widely expressed serotonin receptor throughout the body. It's in just about every cell. It's in bone, it's in muscle, it's in eye, it's in skin. It's everywhere. And out of all 14 serotonin receptors, it's the most widely distributed. So what was it doing outside of the brain? Not many people had looked at that. And what we have, first we looked at cell-based models, and then we went into animal models, and we've shown in disease models, in asthma, inflammatory bowel, in cardiovascular disease, in rheumatoid arthritis, that we have really profound and potent therapeutic efficacy. And we are looking at mechanisms now, and what's the mechanism underlying this. And our results to date indicate that it's not the same cellular mechanisms that are responsible for increasing the neuronal responsiveness. There are different pathways that are being activated, and we're trying to track those down now. Another interesting thing we found is that different psychedelics are having different anti-inflammatory effects depending upon what the disease model or the cell is. And some psychedelics that are very potent in humans and in animals have absolutely no anti-inflammatory effects, whereas others that maybe aren't very behavioral have really potent anti-inflammatory effects. Like, for example, LSD is not a very good anti-inflammatory.
Yeah.
Even if we give a high dose, it doesn't really rescue the inflammation all the way.
All that microdosing, just all for naught.
But on the other hand, psilocybin is a very potent anti-inflammatory. So that we can very powerfully prevent inflammation in several of our animal models. And so we've been doing a lot of structure analysis to try to figure out what's going on, how these drugs are interacting with the receptor. But if you think about it, how many people in the world are suffering from really chronic inflammatory diseases? As you age, you've got your back hurts, you've got your neck, you've got arthritis, and it seems like these chronic inflammatory diseases are the ones that respond the best to some of these psychedelics. And it's been somewhat difficult to study because it's not like a typical anti-inflammatory. If you take a normal animal that's not sick and you give it a psychedelic, even a high dose of psychedelic, it doesn't do anything to the immune system. The immune markers are all right there. Whereas if you give a corticosteroid, you're suppressing the immune system. So one of the side effects from a lot of biologics and steroids is if somebody is taking one of these medications for a chronic condition, they're more prone to develop opportunistic infection, reactivation of tuberculosis, things like that. But with a psychedelic, they don't do that. They don't have an effect on the baseline immune system. That it's not until the system becomes essentially sick and inflamed, the psychedelic will then become active and bring that cell back to normal. So it's more of a return to homeostasis medicine than anti-inflammatory, but it has several really promising, potent indications. So it's keeping me busy.
Yeah.
Trying to figure this out.
But I do think it's really interesting of not only do these have applications within psychiatry, but also immunology.
Right.
Sense.
And as you alluded,
disciplinary.
Yes, and as you alluded to as well, neuroinflammation. There's a large fraction of psychiatric disorders ranging from depression, substance abuse disorder that all involve neuroinflammation. So it could be kind of a chicken or the egg. Was it the neuroinflammation that led to the psychiatric disorder, or was something that happened that led to the neuroinflammation? So the anti-inflammatory effects of some psychedelics could very well conceivably play part of the therapeutic role in reducing that neuroinflammation.
Yeah, really interesting. And Hamilton, I'd love to turn to you. Kind of another mechanism is neuroplasticity. We can certainly talk about that. One other thing maybe we want to hit on too, we're kind of using the term psychedelic loosely here. People kind of bucket ketamine. We've talked about the serotonergic agonist, which is sort of the purest definition of psychedelics, but I see kind of ibogaine, sort of other classes get bucketed in. Maybe you want to hit on kind of the wide ranging of mechanisms those cover. Some of those do tend to be neuroplastic, so if we want to hit on that, can certainly speak to that as sort of another biological marker of psychedelic mechanisms.
Yes, sure. And I don't do any research with psychedelics and neuroplasticity or even really pharmacology. All the work I do is chemistry and chemistry of classical psychedelics, not non-psychedelic psychedelics. So when I discover something that has low 2A affinity, I don't look at that necessarily as a good thing, but it almost depends on what lab somebody's working in and what model of the therapeutic activity of psychedelics they are pursuing, because what happens with drugs in general, not just psychedelics, and actually this probably has more overlap with the way journalists think than the way scientists think, is you construct narratives to describe why something does what it does. And that applies to both positive and negative effects. So you see spinogenesis in rodents that are treated with cocaine, and you say, there you go, that's why it's addictive. It's because of the new dendritic spines reinforcing the addiction pathways. That's why it's not a good drug. Then you see spinogenesis caused by a psychedelic, and you say, that's why they're therapeutic. That's why, because they're reinforcing those constructive pathways. And so there is a way of overlaying a narrative onto biological observations that could be in and of themselves value neutral, but we are trying to contextualize what we're seeing to explain why it is the case that many people are experiencing a therapeutic effect from these drugs. We've also seen this, for what it's worth, with SSRIs, right? The original selling point of SSRIs was that depressed people have some kind of deficiency of serotonin, and by blocking the serotonin transporter, you're going to increase synaptic serotonin, correcting the imbalance. But that turned out to not be quite right. So then you shift the focus and say, oh, maybe it's a hippocampal neurogenesis. Maybe that's why the SSRIs are good. And you keep kicking the ball down the court, trying to figure out an explanation for why these things do what they do. And that's just part of science. The same thing has also happened with ketamine endlessly, right? Is it mTOR? Is it the one diastereomer of one isomer producing a metabolite that interacts with some subtype of nicotinic acetylcholine receptor or whatever, and on, or an anti-inflammatory effect, which is also plausible. And you can even find that in drugs that are used outside of psychiatry. Like probably a lot of people in the audience over the age of 50 take statins. Statins are used to prevent atherosclerosis, but there's also some somewhat limited finding that suggests that the anti-inflammatory effect of statins may also confer an antidepressant effect. So you can find any number of different explanations for how these things do what they do that may not necessarily be valid. Now the really fashionable one is synaptogenesis, neuroplasticity changes, spinogenesis, dendritic remodeling, all that kind of thing. And I think it's compelling, it's worth investigating. But I think when you look at it in the broader scheme of the way psychoactive drugs are studied, you will find that this is not a unique effect of psychedelics necessarily, or even a unique effect of drugs. Like probably everything, in fact, certainly everything is going to be causing changes in dendritic spine density. And I think we need these explanations because a lot of the fundamental questions remain unanswered. Like really basic questions remain unanswered right now. Like, for example, 5-MeO-DMT is a psychedelic that produces a really profound alteration of consciousness that many people consider therapeutic. LSD is also a psychedelic that produces a profound alteration of consciousness that many people consider therapeutic. But one lasts for 15 minutes and the other lasts for 8-10 hours. So from a clinical standpoint, in terms of the labor required by therapists, there's an enormous difference between these two, and patient accessibility could be dramatically improved with short duration psychedelics. But is there a cost associated with that? And if so, how do you measure it? And so people take it back to the dendritic remodeling. They say, well, if you compare psilocybin and 5-MeO-DMT, yes, they both cause, increased dendritic growth, but the psilocybin is causing the head of the dendrite to enlarge, and maybe that is what really matters. Maybe, but maybe we just don't know, and it's going to be a little while before we figure a lot of this stuff out. But in terms of you asked just about all the different mechanisms.
Yeah.
There's a lot. But with the classical psychedelics, they're primarily agonists at 5-HT2A, as David Nichols said, and the tryptamine psychedelics often also bind to 5-HT1A. The ergolines have more interesting polypharmacology binding to dopamine receptors. Things like ibogaine have pretty promiscuous activity at a lot of different types of receptors, including the NMDA receptors that act as a antagonist and nicotinic acetylcholine receptors and a lot of different monoamine transporters. So that's a drug that does a lot of different things. And exactly what value, if any, these different constellations of pharmacological activity confer is not clear. I mean, there was well, you can stop there.
Yeah, no, but really helpful that there are a wide variety of mechanisms that all can induce a highly psychoactive state. And I agree on the neuroplasticity debate. I mean, biology is complex, and we have this debate at Palo Santo. Is it maladaptive? Is it adaptive? I do think, kind of dopaminergic drugs like cocaine, for example, that's a mesolimbic pathway versus these being serotonergic. So again, could be in different brain regions, but there's a lot to still understand. And there is, one major company in the space, Delix, that's kind of pioneering this, Dave Olson and his work. But I think the debate will rage on whether there's a neuroplastic mechanism. So I think we've established there is a biological layer to how psychedelics are working. Now I want to get to the fun part of the debate, less kind of science class, more debate and discussion. And that is whether we need the trip to induce a healing effect, whether there is some real value to that psychoactivity, or if the psychoactivity is a byproduct of something going deeper, kind of going on at a deeper layer in the brain. And perhaps I think we have this debate in science of what's correlative versus what's causative. So are things correlating with a deeper biological mechanism, like is the trip correlating, or is the psychoactive experience mediating some therapeutic effect? So Dave, I'd like to turn to you for Steve Ross. Dr. Steve Ross at NYU did a lot of work with cancer patients and kind of said that the ability of psychedelics to get to more, existential qualms and kind of some of the deeper existential questions folks have suggests maybe there is a psychological mechanism at play. Curious, do you agree with that? Do you think there is a biological substrate somewhere in between? I know I'm giving some directionality, but want to kind of, give you a clean slate to opine also on this overall debate.
Well, if I'm a complete reductionist scientist, I'll say that all the psychology is a result of some biology. Now, I think in many cases, the psychology is important, and we can talk about the non-psychedelic psychedelic, which is, doesn't compute for me. But if you can develop a drug that activates, say, the serotonin 2A receptor and doesn't produce the behavioral effect, that could be very useful in major depressive disorder, just like SSRIs. You don't need that to happen. That's a vast majority of patients. But in my opinion, Steve Ross worked with cancer patients. So did Roland Griffiths at Johns Hopkins. I think the behavioral effects, the psychedelic effect, is critical for end-of-life patients and substance use disorder patients. So I've seen a lot of interviews of some of the subjects that were in those studies. So someone who's at end of life in existential distress, I don't believe you're going to be able to ever give them a pill that's going to take away the fear of death and all the anxiety they have. When they get a psychedelic experience, they go back and they look at their life in general. They do a life review. They look at their relationship with the siblings and parents. They look at the meaningfulness of their life. What have they done? What have they contributed? There's one fellow from the New York University study that had become estranged from his brother for 10 or 12 years. And in the psychedelic experience, he said, "This is crazy. He's my brother." He got back in touch with him. So these bonds were restored because of the psychedelic experience, looking at this perspective you get with the psychedelic that you don't get with anything else. The same thing is true for substance use disorders, I think alcohol use disorder. I heard an interview with one of the fellows at New York University that was treated for alcohol use disorder under Michael Bogenschutz's protocol. And he said, "I went back and I saw when I started drinking and why I started drinking, what the basis for my drinking was, why I continued to drink. I looked at my people, my family, and how I was destroying what I was doing to my family." That's an insight he got from the psychedelic experience, which I don't think you'll get from a pill. So I think it may be context dependent. You may well be able to develop a 5-HT2A agonist that has selective effects on depression, like an SSRI, but maybe more efficacious and longer duration. But I think there's other cases where, especially end of life or substance use disorders, addictions, where you actually need that psychedelic experience because it gives you a unique perspective into your behavior and how you're interacting with your siblings and relatives and environment. So I think the behavioral there is very important. But again, I think it results from what Stan Groff said. These are unspecific amplifiers of unconscious processes. You're bringing things to the fore that are always under that layer of conscious awareness, but you're not aware of what's happening. And the psychedelic brings that out, and you see the things that you've been running from, that you've been afraid to face. So I think the psychological experience is necessary, but I think it's reflecting the underlying biochemical effects in the neuronal networks.
Yeah, that's really good. And I think you hit on a good point too, that non-psychedelic psychedelic isn't a great way to put it. I mean, technically, these would be serotonin 2A agonists, but that don't have any psychoactivity associated. But
right.
That's some nuance. I may use the term psychedelic for now, but that's what I mean. And one quick follow-up to that too, you were hitting on the need for a hallucinogenic experience, for lack of a better word, for certain indications. Do you think there's value in kind of these long duration sessions with a lot of surface area to process? I mean, Hamilton hit on 5-MeO. DMT is something commercially potentially more palatable and more accessible, but that's very rapid, as we know. Some of it mediated by pharmacokinetics as well. A lot of people, are vaporizing it, so maybe you can prolong that. But could there be, still some value to the psychoactivity with shorter duration psychedelics?
Certainly, there could be. I'm not aware of to what extent 5-MeO-DMT has been used for treating substance use disorders, but it could be. I don't know that the duration is so critically important, except in the case of, say, existential distress at end of life. Those people need a long time to review everything that's happened and gone before. They're long sessions. With addictions, it's the same thing. You have a lot of material to cover. So a quick wham, bam, thank you, ma'am kind of effect.
Got to trademark that.
Yeah. I think somebody else came up with it. But I tend to think that the long duration is probably beneficial for many conditions, not necessarily major depressive disorder. But for things, like I said, existential distress and addictions, to spend the time to look at what happened and then resolve those issues during the process. And I don't know that that will happen necessarily in a very short period of time. Certainly for someone who's depressed, synaptogenesis, dendritogenesis, that could happen very quickly. So for a very short-acting drug, that could be possible. That brings into the question, the scalability. That's the big issue now in psychedelic-assisted therapy. The studies that Heffter funded at New York University and Johns Hopkins, I asked Steve Ross, I said, what do you estimate it cost per subject in your studies? And he said, about $25,000. And so you're not going to get insurance reimbursement for that kind of thing. So there's got to be a push to figure out when do you need a longer action and when can you get by with a shorter action in order to justify it to insurance companies. Because you can't have somebody who's addicted to cocaine come in and say, well, we can cure his addiction, but it's going to take 2 sessions at $20,000 a piece, and nobody's going to pay for that. Or many of those people are indigent to begin with.
Can they pay in Bitcoin?
Most of them don't have a clue what Bitcoin is. So I think it's context dependent to a certain extent, what you're trying to accomplish.
Yeah, that's really helpful. And Rachel, I'd love to turn to you. Again, as a clinician, your views on whether the psychoactive experience is needed, and also kind of this debate over long duration versus short duration as well.
So I'm going to answer it as a scientist, because I'm a scientist also. And I think that this idea that everything stems from the biological and goes outward, it's a feedback loop. How does our biology get activated by the external environment? In fact, there are a lot of debates about whether our biology causes our anxiety or our anxiety reflects back and causes our biologic changes. And that's why I really appreciated, Hamilton Morris, what you said about how we tend to use biologic data almost as a Rorschach. We just put whatever interpretation we need at the moment onto biologic data. What I think psychedelics are doing is they're acting like kind of a psychological enzyme. They're connecting 2 kinds of experiences, and you're coming out the other end because of your ability to bring in the mind and the body. I mean, psychiatry has really done a great job taking the psych out of psychiatry. Psychiatry is not neurology and it's not endocrinology. There's a biologic basis to mental conditions, sure, but there's a lot of emotional, spiritual, and mental constructs that psychedelics help engage. And so psychedelics are really a kind of connector that will allow a feedback loop, which is why you can then see biologic endpoints at the end. They don't reflect the pharmacologic action of what you're taking. They reflect a change. One of the biggest things that we've learned from mental health, especially from trauma, is that events change us. They change our biology. And so you have to have a seminal event for healing as well. And so this short-term healing with antidepressants, that might have worked over a long term had we not taken out the psychotherapy. I mean, we basically give patients medicines and say, okay, neurogenesis, do your thing. So neurogenesis maybe builds railroad tracks, right? So you have more dendritic spines and more of an opportunity to learn, but you need the material to learn. And so that's what the psychedelic journey is all about. So to take out the trip is to take out the whole thing. Then we would just have, third generation, fourth generation antidepressants that somebody passively ingests and hope that their biologic change somehow matters or makes a difference in their lives. No, you have to engage with the material. You have to engage with your history, with your autobiography. The things that you sometimes see, particularly with the traditional psychedelics, you might have a visit from your great-grandmother who was a slave or a Holocaust survivor, and that might be really important for you to kind of tie in your life together with what is going on for you now and what will happen in the future. That may or may not have a biologic substrate, but in the end, I agree with you that it's the experience of what happens during the trip that provides the grist for the mill that will catalyze the change that will feed back to the biology, and that I don't think that there's a shortcut to it, how long or short it takes. I don't think what matters is what happens during the trip. I think the length of time you want to take in processing and integration is what's important. How long are you going to spend thinking about it and changing and reflecting from that journey?
That's really helpful, and I like that commentary. And I liked your commentary on the recursive nature here. That really resonates. You know, I think within science and in biotech, sometimes we have a bias for linear models of kind of cause-effect, but effect could be looping back to cause in a way. So that's really helpful.
Yeah, I get that from the study of hormones. Why are there hormone receptors in the brain if the brain just is supposed to stimulate the hormonal glands to release hormones? It's all circular. We have to start taking a systems biology approach where everything not only causes the next steps, but are modified by those steps thereafter. And that's why it's so impossible to come up with a biologic explanation for anything. You talked about inflammation. Mm-hmm. Well, glucocorticoid receptor might be at the very heart of that too, and those will be changed by the environment that then will interact with the psychedelics. So one of the things psychedelics should do is make us see interconnectedness in a circular, nonlinear way. And so if we can do that, then we can avoid reductionistic questions like, do we need the trip or do we not need the trip? It's all about the trip. The trip's the whole thing.
Really helpful. And just continuing on kind of this line of inquiry, Chuck, would love to hit on, we talk about I think it came from Bill Richards, if I'm not mistaken. It started with him, this achievement of peak mysticism. Michael Pollan hit on it in How to Change Your Mind, that peak mysticism, you kind of need to achieve this peak mystical state to get a positive therapeutic outcome. We have had this discussion internally at Palo Santo at times of, this idea of receptor occupancy thresholds. So kind of hitting a certain percentage of 2A receptors in the body in the brain. I think going back to this debate of what's correlative, what's causative, would love, again, for you to opine on this debate in general, but maybe kind of splice that in a bit, some of that.
Correlation is not causation.
Yeah.
So it's going to appear that I'm going to start off in disagreement with Rachel, but I'm actually not. Just bear with me. So,
Okay.
so I study animals, and I'm looking at several animal models of depression in my research. I have genetic models, I have stress-based models, and primarily we've looked in rats, and we can generate depressed rats, essentially, and a single administration of a psychedelic will essentially rescue those depressive-like phenotypes. I think we've looked now out to 100 days without any decrease in the efficacy of a psychedelic in decreasing any effects. So rats, as far as we know them, don't really have this existential sense of existence, although maybe,
sure about that?
Maybe they do. I've had these debates with so we see these profound antidepressant-like effects with not only psilocybin, but other psychedelics that are very long-lasting after just a single moderate dose. So that tells us that there's something biological at the core that affects this antidepressant effect. And you may argue, does a rat, maybe a rat has an existential sense of existence, but we've also looked at fruit flies. And in fruit flies, a single exposure to psilocybin produces a long-lasting antidepressant-like effect that's even better than an SSRI in a fruit fly when we look at that. Fruit flies have serotonin 2A receptors. So whatever this mechanism is that psychedelics are using to produce these antidepressant-like effects or positive effects on behavior is very evolutionarily ancient and going back to where mammalians split off from insects. So it's something that really has been with us through evolution, and we're just now finding. So that being said, that I think there's a very good, strong argument to be made for a biological basis for enabling this antidepressant efficacy. Other results that we've also seen in our rat models support what Rachel and my father have been saying, that the environment that these animals are in will shape the eventual outcome. Like, we can take an animal that we have just given a single injection of psilocybin. We could put it in its cage, we can measure it 2 months later and show, oh, it's not acting depressed. It's moving around, it's eating. But if we take that animal, we give it a single treatment of psilocybin, and then we put it in a different environment, now suddenly that animal at 2 months, whereas the one that was just given psilocybin still had normal anxiety. But now this one that we put in a different environment has very profound anti-anxiety effects. So I think there's a biological basis and core that really primes the system for that subjective experience. And to really maximize and take advantage of these insights, to take advantage of that plasticity fully, I think you need that trip, especially under circumstances like my father has mentioned, where there's this existential issues of cancer or substance abuse, that there's a fundamental biological mechanisms shared as far back as insects that are able to take this 5-HT2A agonist to prime the brain to process these subjective experiences for therapeutic benefit.
I just wanted, do you give psychotherapy to the rats as well?
Exactly.
And the fruit flies? Is that part of that? Yeah.
Exactly.
So, some tender loving care.
I just want to comment on your comment. I think that the idea of depression in a rat or anxiety in a rat is a construct that has been developed by psychiatry to be able to justify how they decide that these drugs will help people. And I think it's problematic. So I think the whole thing here is consciousness, that we exist more than just the sum total of our behaviors and our head twitches and our forced swim test behavior and all of that stuff. And until we can understand that that work is critical, yet not complete, we're not going to get to the next level here. And so one of the reasons that I left traditional neuroscience to work in a clinical environment is because I didn't understand why my advisor kept calling what I do rat cognition. They were running through a maze to get some food at the end. I don't know if they were smarter, but we have this way of talking about phenomena in animals and then bringing them to humans, but it stops here. And then what we have to do is understand that we're going to need new mechanisms beyond pharmacology, beyond neuroplasticity, to be able to explore consciousness. This is our opportunity, and the trip is going to provide the opportunity, plus all the human innovation that you see here at this conference and elsewhere. I don't think right now we can explain it, but maybe at the next year's conference, somebody will have developed something that will take us to that next level. I'm sorry, I just had to say that about rat depression.
Yeah. I'm very well aware of, that is a huge issue with psychiatric disorders, because we are uniquely human.
Yeah.
Animals don't get schizophrenia.
That's
They
right.
don't have substance use disorder. They don't have depression. And all we can do is model behaviors that are conserved with humans and try to look at this reductionist biological circuitry. And we've made several discoveries like that. But research animals are not humans. That we are definitely unique. And it's going to require, I think, new tools and new ways to think about how psychedelics work beyond the traditional types of medication. Because psychedelics aren't a beta blocker to help your heart. They're mind manifesting. And humans are the only animals with minds capable of, as we know, of the complex processing and existential thoughts that we have. And so I can't take the brain out of a person and look at it. So I have to use rats and flies. But
Yeah, and we do run into this issue is translatability from preclinical to the clinic. And we know in psychiatry that's a much larger graveyard, I'd say, of failed drugs once we make that transition. Hamilton, I'd love to get your view in this debate. You said you've certainly had a focus on true psychedelic compounds, hallucinogenic compounds, but analogs, kind of novel molecular matter. Would love for you to comment on if there's anything of interest, either from kind of the Shulgin library. There certainly has been some research published on 2-bromo-LSD. A paper just came out by John McCorvey, or Shulgin's Ariadne. Those are non-psychoactive, to be fair. I don't know if those offer some clues of potential kind of non-psychedelics, but would love for you to kind of throw your hat in the ring here in this debate.
Well, I think Ariadne is a good example because this is something that is sometimes described as a non-psychedelic, but I actually happen to know that it is very much psychoactive because I've used it myself, as have many other human beings. And I think this is an example of this sort of mystery surrounding these compounds. If you're just looking at animal models or in vitro work and you say, oh, look, it's doing this therapeutic thing, maybe we're getting all the benefits of a psychedelic without all of the potentially difficult dimensions associated with perceptual disturbances and having a trip. And what Ariadne, for those that don't know, Alexander Shulgin, he had a very long career. He created an enormous number of psychedelic compounds, but one of the ironies of his career is that the only drug that he ever created that made it close to clinical approval, made it to phase 2 clinical studies, was a drug that wasn't prominently psychedelic, and that was Ariadne. And this is a variant of a far more potent drug, DOM. And the idea was, maybe this will help people with dementia. Maybe it could be useful for Parkinson's disease. Maybe it gives people a little cognitive advantage of one kind or another. And it feels sort of like amphetamine with a tiny bit of a psychedelic edge. I would be surprised if it produced all of the therapeutic benefits of a classical psychedelic, but that's not to say that it isn't without uses, and that maybe it is. There's a recent paper by my friend Mike Cunningham that showed that it was as effective as L-DOPA, which is the current standard of treatment for Parkinson's disease, in terms of restoring balance on a balance rod in mice. So again, this is like way preclinical, way too soon to say that those benefits would be observed in humans. But the bigger question of what do all these different drugs do and what kinds of different therapeutic activity might they have. I mean, there was a really surprising study that I imagine some people here read by Matthias Liechti, I may be mispronouncing this, but he directly compared doses of 200 and 300 micrograms of LSD to 30 milligrams of psilocybin. And I think if you ask most people, is there a difference between LSD and psilocybin, they would say, of course. You know, the most obvious one being duration, but you can point to endless differences. David Nichols has done all sorts of work on the interaction between LSD and various subtypes of dopamine receptors. So of course, there must be a difference. But based on this study, the differences were minuscule. I mean, the conclusion of the study was based on these various rating scales that were given to participants, that these drugs were borderline identical, save for duration and small variations in their cardiovascular effects. So that does not connect with most people's intuitive understanding of these substances. And if you extend that further, then where do you go? Do you say they're all the same, all of the different compounds detailed in P-call and T-call, or just variations of a theme with different durations that are absolutely identical therapeutically? I very much doubt it, but this also depends on what participants are looking at, what disorder you're looking at, what kind of therapeutic activity is being pursued, what kind of dosing schedule. And I think it's safe to say that there are differences. I mean, that's not even, there absolutely are differences pharmacologically speaking. But the question is, how will these different types of compounds ramify to create different therapies? And I don't think people have a really good answer for that quite yet.
Yeah. And one quick question, you are right on Ariadne, that it's sort of weakly psychoactive. You know, is there, this is going to get a little technical, but around 2A affinity, you said you kind of leave out things that are weak affinity at the 5-HT2A receptor. Is there kind of an ideal range? Like, do we just think it's sort of the highest affinity is going to have the strongest effect? I think you were hinting there really isn't much difference across psychedelics, but as we speak to affinity,
well, affinity is just part of the pharmacological equation. There's also functional activity at a receptor. So something could have very high affinity but low efficacy and wouldn't produce much of an effect. And then also there's the bigger question, which is, does any of this even matter? LSD, or rather mescaline, is a drug so weak that if I were to have discovered it, I would just say, oh, this is inactive. This is a drug that is certainly not worth pursuing. It barely binds to 2A relative to so many other things. But mescaline is absolutely a valuable psychedelic that has integrated itself into all sorts of religious practices and very likely has therapeutic effect in substance use disorder and probably any number of other psychiatric indications. So this is a very weak psychedelic that seems to possess many of the benefits of the more potent psychedelics. So these are all very complicated questions.
Yeah. Certainly. And there's a polypharmacology involved also. You get on 5-HT1A as well. So, yeah. Well, we are about to run out of time. I guess I'll end with just a quick poll, kind of going on the line of sort of yes, no, or maybe it depends. And I'm kind of gathering there's a lot we still have yet to learn about how these work in the body. But I'll start with you, Dave. Do you need the trip? Do you not need the trip to get a therapeutic outcome?
As I said earlier, I think it's the context.
Yep.
You may be able to develop 2A agonist or some variation for endogenous depression, for people who are just depressed and it's not reactive depression. But I think for end of life, substance use disorders, possibly obsessive compulsive disorder, there's studies now looking at eating disorders. I think in those, the trip involves a perspective of your life, how you got to be the way you are, why you are the way you are, and I think you need the trip for that. But could I just add one overarching thing?
Yeah.
Nixon's drug war started in 1970. Now you're hearing the questions we have about how they work and how good they are. This is a result of 50 years of suppressed research on psychedelics. We could know some of these questions by now, because I was in the field and there was nobody else in the field for years and years. This is a reflection of the drug war and what politics has done to medicine and how it's prevented us from developing new therapies for all kinds of disorders. And I just want to step on my soapbox.
And I know we're running out of time, so I'll just do kind of quick run down the line. We can do more kind of yes, no, it depends. Do you need the trip? Do you not need the trip, Rachel?
To heal or to make a kind of behavioral change, you need to have some engagement with your mind, some introspection. You can't do that just with a drug alone. You have to have some sort of an either psychotherapy or a trip associated with it.
Chuck?
Not for flies. For humans,
Yeah.
I think contextual.
Yeah. Yeah. Context in Hamilton?
I don't know.
There we go. And do we, I see some questions. Guys, do we have time for questions? Is that the implication for folks in the back? Or are we completely out of time? We're out of time. Okay, well, unfortunately, there you have it. I feel like this is sort of the like egg white versus egg yolk or, I don't know, whole egg sort of debate that we have in nutrition. This is kind of the equivalent of that in psychedelics. There's a lot we still have yet to learn, a lot to research, but really enjoyed this discussion. So thank you guys.